quickly introduce myself. My name is James Page. I'm one of the tech leads in the Ubuntu server team. I've worked for Canonical for a couple of years now, and I've been involved in the OpenStack project, mainly on automating the QA activity that we do on OpenStack once it pops out the OpenStack development pipeline and starts to land in the Ubuntu distribution, normally the development distribution. Okay, so before I get into what we actually do on the distribution, I thought I'd give you a quick overview as to actually what's happening upstream in the OpenStack development process before stuff lands in the distribution and goes through the Ubuntu QA process. So for anybody who hasn't contributed to OpenStack from a development perspective, code, fixes, whatever, OpenStack operates a gated trunk. All code is peer-reviewed through a tool called Garrett, which provides the project leads and the core developers of OpenStack the ability to be able to accept code from any contributor. That code is peer-reviewed, +1 by an appropriate person. It then goes through a basic set of integration tests, which are provided by a tool called Smokestack, which does some VM-based testing to ensure that the code doesn't break any of the key deployments that OpenStack are testing for. Assuming that stuff passes, then it goes through a process that's facilitated by the Jenkins continuous integration solution that OpenStack operate, which takes that change, does a full unit test on it, and assuming that passes, it then commits those changes to trunk. And that's what we mean by gated trunk. OpenStack project is also doing some bare metal testing. They're using some quite cool stuff around Ubuntu Orchestra, which was the predecessor from Ubuntu 11.10 onwards until 12.04. So it only lasted a release, which has subsequently become Ubuntu Maz, which I'll talk about in a little bit. But using that, they're able to do some basic bare metal testing of OpenStack on actual hardware as well. So if you're interested in getting involved in contributing fixes to OpenStack, then the URL at the bottom is the one to visit, because it tells you exactly how to get involved and exactly how your code change will go through peer review and then get contributed back to the trunk of one of the OpenStack components if it all goes through the QA process. I guess the key message I'm trying to get across here is that QA is absolutely baked into the development process of OpenStack. Everything goes through peer review, goes through testing prior to landing in trunk. So trunk is actually pretty stable upstream. It does have bugs, but some stuff does creep through, and that's what we're trying to address in Ubuntu. So one of the key challenges with OpenStack is the sheer complexity of an OpenStack deployment. This is a graph that we generated from our lab showing a minimal OpenStack deployment. We've got Glance, Nova, Horizon on the far right hand side, Keystone for authentication, Nova Volume for block-based storage presentation to instances. It's all backed by RabbitMQ messaging and MySQL database. And there's a lot of interactivity between services, so it's pretty complicated to deploy. Also supporting all of this stuff is a number of other services which aren't directly developed by OpenStack. So KVM, Vert, Open vSwitch, LXC, all these things go to supporting a healthy OpenStack deployment. And what we do on Ubuntu is we try to test the entire ecosystem of what supports an OpenStack deployment on hardware regularly, to make sure that if you install the Ubuntu packages, you're getting a good experience and everything is working top to bottom. The other challenge we have is multiple releases. So recently announced was the Ubuntu Cloud Archive. The Ubuntu Cloud Archive allows you to use the most recent versions of OpenStack on the most recent Ubuntu long-term support release, which in this case is 12.04. So in addition to OpenStack Essex, which actually shipped on 12.04, you'll be able to enable the Cloud Archive and use OpenStack Folsom on 12.04 as well. So over time, this is going to become an increasingly heavy burden on the Ubuntu server team, and that ultimately we're going to be having to support 4 concurrent releases of OpenStack on Ubuntu 12.04 and 5 across a number of different releases of Ubuntu as well. So in addition to the complexity of OpenStack, we've also got an additional dimension that we're having to test and support multiple releases as well. So we've come up with a QA solution that allows us to automatically test all of this stuff. So we're able to feed the system with on a per commit basis from Fossil Trunk, Grizzly Trunk when it opens, and from the Essex stable branch, which allows us to support both kind of bleeding edge development testing plus stable release testing, so that we can push back fixes for stable release updates into release versions of Ubuntu and release versions of OpenStack on 12.04 and subsequent releases. We also use this for testing any proposed packaging changes, which is an additional dimension which is not tested by the OpenStack project, because the packaging around OpenStack is done by the Ubuntu project. So we're able to feed proposed changes to our packaging into this system as well. Everything for all the core components and all the clients for the core components in OpenStack, we then go for a package build test cycle. So we make sure packages build. Most packages have some sort of unit test suite that's executed during the build process. And assuming that that build completes successfully, we publish those packages both in testing PPAs, so anybody can grab these packages that are coming out of this process and try them themselves, and quite a lot of people are doing that who are involved in QA in OpenStack upstream as well. We also publish all of the test results to the main Ubuntu Jenkins QA instance as well, so all of this is publicly visible as it happens on a day-to-day basis. Once the packages have been through the package build unit test cycle, they then go on to a deployment test. So we then deploy OpenStack onto bare metal with the packages we just built to validate that we're able to deploy and use the OpenStack trunk or OpenStack Essex stable in the case of previously released versions of OpenStack. So how do we do it? So we have a test rig of 12 servers. One of those servers acts as a control node for the rest of the lab. It runs, amongst other things, Jenkins. It also runs Ubuntu MAS, Metal as a Service, which does all our physical machine provisioning. And we also use Juju, which is the Ubuntu service orchestration tool, in conjunction with MAS, to deploy OpenStack onto the physical hardware. The localized build process we use is very similar to what happens in Debian and Ubuntu anyway. We use sbuild for doing clean run package builds, and repreco to actually build a local archive within the lab that we can then use for testing on a very, very regular basis. In terms of testing our deployed OpenStack, we use the DevStack exercise tests, which is a basic validation test that if you've used DevStack, which is the way if you want to install all the development code that is in the current development release for OpenStack on a single node and do testing of your changes, that's the way you would normally do it. So we use the basic commissioning script that DevStack provides. We run OpenStack Tempest, which is a much more in-depth integration test suite, which is developed as part of the overall OpenStack project. And we also do a number of basic tests using Juju, our service orchestration tool, to actually deploy services onto the cloud we've just provisioned on hardware as well. So we're using Juju both to deploy the cloud and then to deploy things into the cloud. It can do both levels of abstraction. We have a whole load of glue code that sticks this together called OpenStack Ubuntu testing, and that really provides all the Jenkins job configuration, the control of the overall build process, the configuration of the environments that we're going to be deploying. And we have a few hacks on top of the kind of the basic tooling there. We do some pretty clever stuff with LVM snapshots on the physical servers themselves. So at the moment we're testing precise and quantal releases with OpenStack. So we actually have a gold copy in a LVM volume, logical volume, on every server. And then as we actually provision those servers, we form a copy on write root volume, so that we don't actually have to completely reinstall Ubuntu every time we want to do a test run. And by taking that approach, we're able to deploy a 11-node OpenStack deployment in about 15 minutes. And just to give you an idea on the volume of cycles that we're putting through in a 12-month period, I checked the counters on numbers of deployments this morning, and we've done about 3,500 deployments of OpenStack in the last 12 months in our lab. I have to admit, that was about twice what I thought we'd done, but Gigi gives us some monitoring on how many times we've deployed units. So what are we looking to do in the future? We want to increase our coverage. We need to get better on Cinder, Quantum and Swift to make sure that we're lining up with the core projects in OpenStack. We want to start including some of the wider OpenStack ecosystem that's developing. So Ceph provides a very compelling scalable storage solution, which is a very good complement for OpenStack. We spent quite a lot of time in the last development cycle looking at that. So I'd really like to start including some Ceph testing as part of our overall OpenStack deployment testing. We need to integrate with upstream development processes. We've not been particularly brilliant at that. We have pre-commit testing functional not in our live lab, so we're not feeding back to the OpenStack Gerrit peer review system yet. But we hope to be doing that at the beginning of the next cycle. So in addition to getting some smokestack feedback on your proposed change, you'll also get some feedback from the Ubuntu distribution on how your change is going to impact what we're doing downstream in Ubuntu. Automated upgrade testing. Doing some basic testing at the moment in terms of moving between releases, so Essex to Folsom. We want to do much more in-depth testing on a much more regular basis to make sure that the upgrade paths for routine OpenStack releases work really, really well. And stress testing. So I can see us putting the lab aside for a weekend and running a 2-day continual cycle instance creation deletion stress test on a regular basis, and that's something that I very much want to do on the next development iteration to prove that everything hangs together when run under stress for a longer period of time than the 30 minutes the lab is normally up, because then someone commits upstream and we do it all again. So I hope that's been informative. The bottom of there is a very long URL, none of you will ever remember, so I'm hoping that maybe I can send this pack round after the event with a lot more detail on exactly the process we're going through to deliver this solution. I found it interesting, so any questions?
It's quite interesting what you're doing. Is it a nice framework for perhaps deploying to production systems as well? You know, obviously it's mainly focused around you doing QA for your releases. It seems like you've got quite a lot of the bits you might want if you were regularly deploying in a lab or production system that you're using.
Yeah, so the Charmed, Juju is the orchestration tool, Charms are the definitions of services. So the Charms for OpenStack that Adam Gandelman and my team wrote were designed for deploying OpenStack on physical hardware. We've repurposed them for doing QA as well. So yes, with Juju and Matt, yes, you can deploy OpenStack on hardware in this type of scenario, and that's designed for hyperscale deployments, so multi-thousand node deployments.
It's also probably worth mentioning about the last ODS demo.
Was that when we deployed on stage? Yes. Yeah. So the process that we use in the lab, we demoed at the last OpenStack Design Summit. So Mark Shuttleworth gave the keynote presentation at the Design Summit, no, the summit after the Design Summit.
He took the risky move of trying to deploy OpenStack live on stage in front of like 1,200 people or so himself.
So it must work then.
Well, you would think so.
We practiced a lot.
No, it just worked.
But no, we used exactly the same technologies in that demo to provision from. We used the HP microservice. We had 10 of them, on a bellboy carriage that was wheeled in to deploy OpenStack on stage in about 12 minutes while Mark did his keynote. So that was quite exciting. But it works, and it's reliable. As I said, we're doing this about 3,500 times a year. It takes 12 minutes. We're doing it per commit. So, and we do pick up bugs, and we do feedback-based things upstream, and often they're not upstream bugs, they're packaging bugs, because we're also testing our packaging process through that as well.
Yeah. Cool.
Is there any testing of API compatibility? Do you test old API clients against new versions of OpenStack, or new versions of OpenStack clients against old versions of OpenStack core projects?
No, we don't.
Snapshot-based testing, and then sort of grab what's there now,
we're not doing any level of regression testing in terms of API compatibility. I think we're dependent on what's happening in the OpenStack project for that sort of thing, which I don't believe is much at the moment.
We'll get OpenStack API testing by when we eventually add the Juju testing, right?
Yeah, but we already have the Juju testing.
Is that actually right?
Yeah, I think so. I checked this morning what was running, and that's
So we do actually test the OpenStack API works for a minimal subset.
Yes, we do. Yeah.
That's all released on Launchpad. All the charms and.
Yep. Yeah. So
Everything's in the open. There's nothing.
yeah, there's nothing
no
that's
secret sauce.
proprietary or closed here. So the charms are all available through the Juju Charm Store. Maz is available in 12.04 and will be updated in 12.10 and
Naturally, so.
made available on 12.04 in a newer version as well. Won't it, David? Yeah.
Yeah.
So it's a fairly new project, so it's only been around for about 12 months now, so it's still developing, but we're trying to address some of the issues with existing provisioning systems in delivering that multi-thousand node deployment from a single provisioning system.
So maybe it'd be quite interesting in other people having a go with it as well and maybe contributing to that.
Yeah.
Yeah.
Cool. Any other questions?
What are the complexities attached to pre-commit testing?
I think the biggest challenge is not executing the testing, it's actually ensuring the quality of feedback into Garrett. So there are a number of things that can fault during testing, so we do get the occasional deployment failure. Our most packaging does occasionally break stuff. So there are a number of factors that may cause test failures. So had we been entirely sure that none of those things were ever going to happen, actually enabling pre-commit testing with feedback would have been incredibly simple. But I don't want to chaff OpenStack Garrett with lots of useless information because people start ignoring the opinion of Ubuntu QA if it's always rubbish. The complexity there is that we've had to build a system where we can review results before they're then posted back upstream into the OpenStack Garrett review system. Because we want to filter them, we want to make sure that we're giving valuable feedback to the contributors who are trying to get their code into OpenStack. Otherwise it will just be, oh my god, there's Ubuntu QA telling me it's broken again, I'm just going to ignore that. And that's not just for contributors, for the tech leads and the core developers who are going to be reviewing that code change as well. So it's really been about ensuring the quality of feedback into Garrett upstream.
Are you triggering on every commit upstream?
Before that stage, so when you've
Pre-commit,
made a change that you want OpenStack to include in trunk, so you push that up to Garrett and say, can you please review my change?
Right.
And then there are various testing bots that come on and watch all of the changes that are being proposed, run a test, and if it fails, then it posts something to the change thing, so then reviewers know that you need to go and fix that before they need to look at the code.
Okay.
So it kind of
you're
saves
one of the core reviewers that our feedback in. Okay.
When I was looking at overall upstream documentation, I found two Jenkins instances. There's one that builds Ubuntu packages, and there's one that builds targles and also runs unit tests. I'm just curious, one seems to be managed by Ubuntu, one seems to be managed by OpenStack. What's the relationship between the two?
Limited at the moment. So Jenkins.openstack.org is the one that will be building targles and running unit tests. I'm hoping. Definitely not doing that in Ubuntu. And in Ubuntu we're doing package builds and system testing. They're managed by two completely separate organisations, so Ubuntu and OpenStack separately. So Monty Taylor and James Blair, who work for HP on the OpenStack project, manage Jenkins OpenStack. Myself and Adam Gannon mainly manage the Ubuntu OpenStack. The Garrett link is really the link between those two things, and that's really what we want to implement next, so that we can start feeding back Garrett's really the orchestration point between all of the continuous integration and testing activities that happen in OpenStack and in Ubuntu. But we need to start feeding our results back so that we can add some value there.
But just to add to that, there is good communication path between the two projects. to work out ways of better integrating them together. And next cycle we're going to see much tighter integration than what there is at the moment.
So there's a really good way of all the different people who use OpenStack feeding stuff back. So generally, they wait till they deploy it on trunk, realise something's broken, and then file a bug. But the pre-commit testing is about doing that before it gets to the point where people are deploying on their things, finding bugs and reporting them, so they can do it on changes as they're being proposed. So it's just moving that all up a stage, so trunk is a great deal more stable. I mean, you're essentially finding the same problems in the end, you're just doing it a lot earlier.
But the other thing which I think James touched on was that as James has described here, it's the only testing which is currently on bare metal. Upstream testing itself is purely virtualized, and we feel that there is advantages to also having additional testing on bare metal. So it basically is a bit of an ecosystem that comes together to create quality together rather than just having one single testing process.
Okay, I think we have to call that time now because we need to swap the rooms for the tracks. So
Thank you, James.